demo of our website. Here's our home.html. It has a brief description of our product and a button that's inviting you to start monitoring or signing up. We can go home. We're home. We go to the index. Here it showcases our pitch video. Here's where the demo video is going to go. We have the Drift team. That's us. Name, picture, and description. Name, picture, and description. Name, picture, and description. Then we can go to references. Here it showcases all the libraries we used. If you click on one of them, it takes you to a correct website referring to each library. Let's go back to home. We can start monitoring. So let's try to register with nothing. We're missing everything. So let's start with a name. I'm going to be Saul. We register. Now we need an email. Let's try Saul. That's in valid format. So it'll be saul@testing.com. That'll be correct. Now we need a password. It's going to be password 1A. And then password 1A. They match, so it takes us to a user login now. We can use saultesting.com. And now it takes us to account information in our account. We can edit this. So I'm going to be Saul2. Save changes. Now it reflects it here. We can change our password to now password 2A. And then password 2A. So we can save those changes. And now we log out. Go back in. Let's write a new password. Password 2A. Oh, it's capital P. Now we're going to be able to log in. So now we can go to devices. We have no devices because this is a new account. So let's start adding devices. 1, 2, 3, 4. Let's try longer names. It gets sized automatically to a length of the name. So maybe I go device 1. And it's not letting us because this device is already registered with a different account. So we want to have unique devices per account. So they cannot be sharing devices, and that way you don't know who the data goes to. So instead we go device 11, then device 111, and as you can see, it makes a new row because there's not enough space for that device here. Let's get rid of this one. Oops, let's get rid of this one. We deleted it. We can go to account, devices, the devices stay there. Let's grab this one, let's modify, maybe -10. It needs to be a positive value. Okay, so let's do 10. Instead of 6, let's do 3. The end time has to be greater than the start time. So let's do maybe 1 here. And so it's 10, 1, 3. It got updated correctly. Let's try to add the same device. That's device 11 here, device 11 here. It should not let us. It's already registered. Okay, makes sense. We can go to our heart. Here's where it would display data, but we don't have any data. Here are the graphs. We can change from heart rate to saturation. And we can also change to like different dates. So let's go to an account that has information in it. That's admin. It has its own name, email, devices. It has its devices. Let's try to add a device that was already in the other account, for example 1. It's our eraser, so it won't let us. It has its own frequency already set, start and end time. We can modify this too. Maybe let's try to break it with 100, with 90. It's not valid because it's not below 60. So let's do it 59. And it stays like that. Okay, so now we can go to our heart. It tells us daily average for BPM, weekly average for BPM, and also SpO2. Daily minimum, weekly minimum for BPM and SpO2. And daily maximum and weekly maximum for BPM and SpO2. Here's today's measurements. The graph gets updated depending on how many data was recorded. So it's only 2 recordings. And here's the weekly view. We have black, meaning the maximum, red being a point in between, and blue being the minimum. So this is minimum, this here is maximum. Let's change to blood saturation oxygen. We have two that are the same value, so they're the maximum. Here's how it looks. Maximum, minimum, in between. We can now change to a different day, so let's go to yesterday. We have maximum, in between, minimum, and now it's updated with more information, and it shows you the exact time it was, and it increases depending on how much data you have on the graph. We can go to heart rate, maximum, minimum, in between, same thing, maximum, minimum, in between. And we can go to a different week. Let's go to this week. It displays no data on the week because it's a different week. But if we go to maybe Wednesday, oh, it's November. If we go to December and then Wednesday, it displays the data of the week even though there's no recordings for that day. And that should be all for the demo. Everything is working correctly. We can log out one more time and go to home. Thank you.
Now we're going to take a look at our web server that's running in the AWS. We're going to start with app.js. We started by importing all necessary modules. We set up the routers for the different endpoints. We started Express application, set up the view engine, all the middleware. We put routers, make our functions are handled for errors. And then finally we create our server on the 8080 port. We also have a MongoDB.js, and here's basically connected to our database that's in this place, but now running on AWS. Now when we go to each folder, we have keys. User key has the JWT keys that you use to encrypt or decrypt. We have our models. We have our model for device. We have a device ID that has to be unique, and API key to connect from the web server to the device. Range start is when you can start taking measurements. Range end is when you have to stop taking measurements. Frequency is how frequently you want to take measurements. BPM measurements is the heartbeat measurement. And SpO2 measurements is the oxygen. And we have our heart rate, and SpO2, and a unique standard that we later on convert to a date. For user, we just need a name, email, password, and an array of devices so the user can have more than one device. Now we move to our public folder. We have our images. That's basically every single image that's being used on the server. We have our JavaScript. We have one unique one per each HTML. So I'm going to run quickly through some of them. So for account, it's once we're ready, we have to have the option to sign out. We have to fill the data from the user. We have to have the option to edit, save all the changes that the user inputted, to have the information, just make it so it's able to hide and show information easily. Same thing for passwords, have an option to sign out and remove the token, fill data with an AJAX call, getting the data from the database to update the server, to update the web page, and it displays your name and email from the server, from the database. And now grab the data that the user inputted and update the database with that. Data.js is the one that displays all the user information returning to heart and oxygen. This one makes calls to the user. From the user, it gets all the devices' IDs. From the devices' IDs, it gets all the measurements. From all those measurements, now it filters through week and through day and processes all that information correspondingly, and then updates the graphs and minimums and maximums correspondingly. I'm just going to go quickly through the code. Okay, for device, it's similar. You have to have the option to show the devices, do something where there's no devices, do AJAX calls from the user to check all the devices, be able to update the frequency by AJAX calls. For example, add a new device, the registered new device that has to be added to the web server, to the database, and also to the user. Remove device that has to update the user and also the database. Of the device, you find that device that you're using right now, you configure a new device, and you have the information there. Home is the most simplest one, it's just being able to take it from one website to the other. Index 2, I'm going to skip login and sign up, but it's basically a bunch of validation of the user, and doing AJAX calls. For the styles, it's basic styles, and we have the HTML. So we have 3 routes: device, index, and user. For device, we need to be able to register a new device. So we find the current user in our database. Then we find the user, we update the device array with a new device, and then we save the data. Delete device, we have to find a user, we have to find a device and delete it. Configure device, we have to find a device and change its parameters. And from the data device, we have to find a device and return out the data inside of it. And for updating from getting the data from the device, we grab the data from the device, we find one, and we modify its measurements array and update the device data from there. For index, it's just taking us from any place to our Express server. And then for user, we have to also create a user. We will have to make sure that the email, we find the email, make sure it's not there already, and then we update the server and save it. Same thing for login. We find that email, we find out a hashed password match, and then let us go through into the account. Post user data, we find the email, and then we return all the data from the user. We update user data, we have to find the user with that data and then update the server. And that's basically it. All the code is going to be uploaded, but that's a simple functionality.
Diving into the embedded side of things, we first start with making sure we include our libraries, where I use a DF Robot Max30102 header library, Arduino particle HRSPO, which I just have headers for my functions that I will present later. So we start out by initializing and declaring a Max30102 sensor object. We also have our states, where we make sure we have a waiting for measurement time, requesting measurement, taking measurement, sending data, and storing data states. We start off with the waiting for measurement time. Here's our timing variables that we will be using to keep track and making sure that we are within our measurements. Next is our start hour and end hour, which are to default 6 a.m. and 10 p.m. Then we have our data to push, which is basically a flag that indicates if there is data to push. If we store to local data, which is this array where we will be storing things. Here we have the update vals, which is a cloud function to update the measurement frequency, start and end range from the actual web application itself, and parses to Spark and make sure we convert it to the appropriate data types so that we could set them here and update the measurement interval and start and end hours, which are done if we ever get a request from the web server. So here's our setup, where we begin by doing some serial communication just for debugging purposes. We have the particle sensor, initialization, some RGB control, just because we're going to be changing the RGB colors of the LED light. And this is where we register the update vals function to the particle cloud, where we can access it from the web server. Particle sensor, we do the sensor configuration, which all of this is denoted on the web API on how to do, so we do that. Then we have SPO2 and SPO2 valid, heart rate and heart rate valid, which are variables that we will be passing in for pointers to the function where we are actually requesting and we're reading data from the sensor itself. So we flash the LED blue whenever we are waiting for measurement. If we are within the time interval and it's time to measure, and then we switch the current state to requesting measurement, and we'll get to that later. Else, if the flag is up that we need to push data and we are connected to Wi-Fi and it's not been past 24 hours, then we publish that data for the heart rate and oxygen saturation, and we set the flag back to false. And yeah, we continue going. Then we reach the requesting measurement, where we flash the LED blue as well, making sure that the current state is now taking measurement. We just switch and we make sure that our measurement time is, we know what our measurement time is, so that we can know if it's been more than 5 minutes if there's no user that's going to be actually measuring the data. So here's our start time. We make sure that there is a finger on the board, on the actual sensor, I mean. If it times out for 5 minutes, which is what this statement is, but then we switch back to waiting for measurement time, and we miss that information. And we just basically keep going here as long as there is no finger on the sensor itself. However, if there is a finger on the sensor, then we make sure it's valid, and we keep on taking track of the 5 samples, which will denote, we try to make it more accurate and so that we can get the most accurate heart rate and blood oxygen saturation. And then as soon as the last measurement is calculated, so that once it stabilizes, we check if we're connected to the Wi-Fi and if the particle is connected. If that is true, we go to sending data where we straight send it to the cloud. If not, we store that data in local data and wait for when we're back online to push that data if it's been less than 24 hours. So here we go into what we're about to send, our JSON format file, our string, where we send in our API key, our device ID, our saturated oxygen, average BPM, and the time interval at the current time, which is given by Unix time. And then we publish that to the cloud. And then we switch our current state to waiting for measurement just because we were finally done. And then here we go to storing data where we're flashing. So the previous one flashes green, the LED green for about 1 second, while this one flashes yellow, meaning that we're not connected and we're going to store the data locally. And so we do the same information. However, now we're going to store it locally and we're going to wait, and we set the flag to equal to true, indicating that data is ready to be pushed. And the rest here are just helper functions that we use to check if the Wi-Fi is connected, if it's been 24 hours, measurement times, and just flashing the LEDs. So here I'm just going to show you a quick demonstration of how this works. I'm actually showing you sensor. So just pay attention to the notations of the actual LED color, and I'm going to show you what is showing up in teraterm, which is serial. You can see that we're waiting for measurement, and as we're waiting for measurement, we see that the current hour is 7, so we're within our time. However, I changed the frequency to 1 minute instead of 30 minutes. I don't know if you haven't noticed that. This is just for demonstration purposes, and we can see how what the flow of the actual process is. So we'll wait for 1 minute. We'll see that we switch up to, in the teraterm, you'll see that in the serial port, we'll see that we're going to switch to a waiting for measurement, and we'll get a bunch of different IR values that will denote that we don't have our finger on the sensor, and we'll see what the outcome is right now. So now we're requesting for measurement. As you can see there, the IR values are low, meaning that there's no finger. As soon as I bring my finger around, you see that the IR value goes up. But once I actually put my finger, this switches to red. And as long as I keep my finger here for the period that's telling me, which is denoted by the red light, I will know when to take off my finger, and we'll see in teraterm and the serial port what our actual final heart rate value and our SpO2 is. So my final heart rate value is 100. My final SpO2 is 99. We sent the data because we're actually connected to Wi-Fi. And then we go back to that measurement. So we're going to see if that reflects over here in the graphs. We see that for today, we only have 2 measurements, just because I demonstrated something right now. But you can see that we should be around 100. And it's very faint to see, but you can see that it's 100, and we actually have a data point right here at this time. Let me just zoom in a little, just because I'm pretty sure that's what the issue is. So 100 right here is our most known data, and you can see it says 016, which is 16 a.m. in the morning. The time here, the current hour, is actually pretty wrong, just because sensor has no idea what time zone it is. So that is a quick demonstration of how the hardware works and the embedded side of things work.